Hi class, this is Course 2, Lesson 51. Today we're going to cover scientific notation for large numbers. Okay, so scientific notation is a method of writing very large or very small numbers. When you have a lot of zeros at the end of a number or at the beginning, if it's a decimal number, they get, it gets to be really lengthy to write out or cumbersome to do calculations with, and so scientific notation helps with that. The format for scientific notation is going to be a decimal number times the power of 10. Okay, this is very important, and this is the part where most students will make mistakes. It has to be a decimal number times the power of 10, but the decimal number has to be in a certain, it has to follow certain rules. So that part is called the coefficient, and it must be only one non-zero number before the decimal. So notice here we have a 2, okay, right before the decimal. That's the only number that can be there. And then it's times a power of 10. Here are some examples of coefficients. So we have 1.8, 5.0, 9.284, 7.003. And it doesn't matter how many numbers are behind the decimal, it's just that there can only be one digit in front of the decimal, and it has to be a number between 1 and 9. Here are some non-examples of coefficients: a 0.44, 12.8, 91.0, 0.13, 18.403. Notice that why they are not coefficients for scientific notation is because there's in the ones where there's 0 point, that's a 0 in front of the decimal, and the other ones have more than one digit in front of the decimal. So this will be very important for you to remember. Scientific notation has to be a number times the power of 10, and that number has to have a 1 or a 1 through 9 before the decimal, and that's it. So let's put numbers into scientific notation and then put them from scientific notation back into standard or decimal form. So there is a place value table on page 337 that shows the powers of 10. They're used for place values. So if it's thousands, it's 10 to the third power. And that might be helpful, but it's not necessary. So here's our first example. We want to write the number 87 million in scientific notation. Okay, so the first thing you do is figure out where you can put the decimal so that you have one non-zero digit in front. So we're going to put the decimal between the 8 and the 7. So we're going to write 8 decimal point 7. And then the zeros we don't write. We would write all of the non-zero digits, but we don't need to write those because that's what this times 10 to the power of something is going to consider while we're doing that. So then, after you write 8.7, so we figured out where our decimal is going to go, then figure out what power of 10 you would multiply to move the decimal from the point that you just put it to the end. How many places is that? Well, it would be 1, 2, 3, 4, 5, 6, 7. So it's 8.7 times 10 to the 7th. So do you see how there were 3 digits here, and there were 3 here, and then there was 1, and then that's where we put the decimal. That's where we get that 7. It's not just the number of zeros. It's how far do you move the decimal. Okay, let's do another one. We're going to write 40,600 in scientific notation. So again, figure out where we need to put the decimal so that there's one digit in front of the decimal point. So again, I have a 4, so I'm going to put the decimal right there. So we're going to write 4 point. Now, remember I told you didn't have to write all those zeros? Well, you do have to write them if there's a digit that's not a 0. that comes after them. So we need to include all of these. So we need to write 4.06. It's these trailing zeros here that we don't need to include here. Okay? So 4.06 times 10, so we have our decimal coefficient, times a power of 10. So what power do we need? So again, we need to count from the place we put the decimal. 1, 2, 3, 4. So it would be times 10 to the 4th power. Now we're going to reverse that process when we write 3.42 times 10 to the 6th in standard form. So scientific notation is that coefficient times a power of 10. And standard form, or decimal form, is when we get rid of the times 10 to the 6th. So we've done powers of 10, multiplication problems with powers of 10, and you know that when you multiply, you move the decimal to the right the exponent number of places. So we're just going to take 3.42, and what I like to do is write it down, copy that right out of your book, just write this whole thing down. If that's the problem you get, put it in your box paper, write it down, and then do this: 1, 2, 3, 4, 5, 6, and fill in with zeros, but then rewrite it. Okay? Nobody writes numbers with all those loops under it. And then I don't know where your decimal is. So write it 3, 4, 2, and then we're going to put 4 zeros behind it, and then put the commas in correctly. So start at the right and go 3 digits, comma, 3 digits, comma. There's your answer. Now the last type of problem, you will have to do some comparison, but you can expand the numbers and determine which number is bigger, or you can look at their powers of 10. But you will need to use words to write scientific notation out. And scientific notation written out is really simple because you just say the digits. You don't have to know place values. So you just say 2 point. Okay, so this is one of the times where the decimal is really said point, not used as an and. So it's 2.9 and times, so we're going to write 2.9 times 10 to the 7th power. Okay, now when it says use words, please do not write the number 2 and the number 9 and the number 10 and the number 7. Write those words out. Okay, that's all I have for you today. Just remember that scientific notation, you can write very large or very small numbers. The format is always a decimal number with a digit numbered 1 through 9 in front of the decimal times a power of 10. Okay, that's all I have for you today. I will see you in class.